Recently, I received an invite from Replitech to come visit their facility. They're a small startup here based in Windsor, Ontario, and they manufacture 3D printer food. I spent the afternoon with them talking about the process of how 3D printer filament is manufactured and touring their facility. I hope you learned something new, and I hope you enjoy the video. Hello, I'm here with Peter and Rishwa from Replitech, and they are a local provider of filament here in Windsor, Ontario, and they've invited me here to do a tour today of their facility here, and I'm going to give them a second to talk about what they do and why they do it. So, how'd you guys get started?
Well, it was last year during the shutdown of the pandemic, when everybody was sitting at home and having lots of free times in their hands, you know that. And basically, we are colleagues at a company here in Windsor, and we are designers. And we do machinery design and tooling, automation. And with this time, we started to play a little bit, thought about building a filament extruder, a desktop filament extruder. We researched a little bit.
It's not as easy as you think when you first get into it.
Well, we very soon figured that out, and extruding filament on a desktop is not the best way to go. There are solutions out there. They are trying to do their best, but it's not easy. The process itself, it's a lot more development.
It doesn't quite scale as well when you try to do a lot on a smaller machine. You need to go to a more professional machine when you want to produce a lot.
But we like the idea of doing filament locally, and we researched a little bit, and we figured that for the economies of scale and to have an economically viable solution, actually you have to go big. So we decided to try it. Lots of filament was coming from China, and we thought that it would be a good opportunity to, especially with the pandemic and all these new economical conditions, to try to do it locally and to see if we can be viable.
So they do have a extruder in the back here, and we're going to go take a look at that later. And they are actually running right now. So we'll be able to see the process of actually turning the raw resin into filament that you can run in your 3D printer.
Yeah, so basically we are doing PLA and PLA blends. Quite a few advantages of PLA material. One of the main being that it is biodegradable. Actually, it's not biodegradable, it's compostable.
Yeah, it will eventually break down. It is more friendly to the environment versus something made out of crude oil, essentially.
Yeah, and it does have a lower environmental impact. There was a lot of research in the last 20 years in PLA field, and they came with the researchers came with pretty good recipes and technologies to make PLA. One of the biggest in the world is NatureWorks. So NatureWorks is an American company. I think they produce maybe 35% of the PLA in the world.
Yeah, that's something a lot of people don't realize is most filament manufacturers aren't making their own plastic. They're not making their own resin. They're taking the raw material, the resin, the pellets, and they're extruding it or coloring it and then extruding it into the finished filament that we're all used to.
Oh yeah, so to produce the raw material, the pellets themselves, there are technologies that are hundreds of millions of dollars.
Yeah, you need a full-on facility just to make
and NatureWorks, for example, they are making hundreds of tons a year. And it's just a small little part of it is used in 3D printing. So they are making PLA for injection molding, they are doing bags, they are doing cups, they are doing cutlery, they are doing all kinds of products using PLA. But growing percentage of this PLA that they produce, it's used in 3D printing. Yeah, so basically we are using NatureWorks 3D 850 resin. We are importing from the States. We have big gaylords of raw material. Then we are loading this resin into a dryer. We have to dry it for maybe 4 or 5 hours because a very important parameter of the extrusion process is the material quality. Depends on how dry the material is.
Yeah, moisture, for anyone who's 3D printing, moisture will kill filament. It is horrible. You get bubbles, pops. Yeah. It's not good. You want dry resin.
So when you print it, it will kill the job, but when you extrude it, it's even more. So it is very sensitive to humidity. So we dry that, and then we run it through an extruder. You are gonna see, and the extruder is basically one of the most important parts of the filament making process. So the extruder needs to have the same as you are using in the 3D printer. You need to have the capacity to melt the filament.
Yes.
Here you need to have the capacity to melt the granules. And melting the granules, contrary to people believe, is not so much the effect of the heating that we have on the barrel, but it is the mechanical work and the friction that the screw itself does have within the granules. So that mechanical work, which gives heat, is probably that heat is more than 60% of the heat that it's used into melting the material.
The screws are like my background is injection molding. The screws are like an injection molding press where they're tapered. It's not a consistent width.
Yeah.
So as the plastic moves closer and closer to the nozzle, it actually gets compressed as the screw widens. So there's less room for the plastic. It gets
exactly.
squished, and compressing generates heat, and that's where actually a lot of your heat comes
from. And the friction that you create in between the granules when the screw is turning. So basically, if you wouldn't have this friction, and the friction in between the granules and the barrel itself, so it depends a lot on that friction, because if you create a layer of liquid plastic, then the screw with the granules will just turn, and it's not going to push anything. Yeah. So you need to have friction in between. So the melting parameters are and the temperatures are very important. So what we have in the screw, so it is very important to have parameters in the screw that it's allowing for mixing. So unlike the twin screw extruders where you actually create master batches and stuff, this one is not good to create master batches, but it is very good to mix all the colors and everything together. And after that, we do have a filter that is filtering everything bigger than,
So like a little piece of cardboard gets in there, and
so
like that.
The material is filtered. And after that is going through the die. Another thing that people believe, and we believe too before we started to learn, is that the diameter of the die determines the diameter of the filament, which is not the case. So basically, the diameter of the die is bigger, and actually when the material is getting out of the die, it's bulging a little bit even more, okay? And what is making the diameter, it's a balance in between. So at some point on the line, you are going to see we have a traction unit. That traction unit is pulling the diameter from one side, and the extruder is pushing from outside. So the balance in between the volume of the pulling and the volume of the pushing is creating that diameter. So if the diameter is bigger, we increase the speed of the traction, it's pulling harder, and it's decreasing the diameter.
Now, is that constantly being adjusted as it's running? So you're constantly changing
well, so that is constantly adjusted, because there are different forces and factors and conditions into the extruder all the time. But of course, we are not doing that manually. So that is controlled by a PLA. So it is a feedback loop, which is telling, okay, go faster because I need to go smaller, okay? And it's gonna do this feedback. You need to have a delay into the command, because basically when you measure it, you measure at this distance, and it is 6 meters
back there,
where it is. So you need to have a delay, and that delay, it's a parameter that we play a lot with to get the right diameter, because if you make it too fast, it's gonna vibrate like that, the diameter. Okay, if you make it too slow, the oscillations are much slower, but then you risk to get out of the tolerance that you are making.
It's better to have something. It's better to have a smoother transition between two sizes than automatically jumping up and down between two dimensions.
And that depends on the material.
Yeah.
Depends on the temperature that we have in the.
Oh, there's so many variables.
It is very, very complex. After it's getting out of the extruder, we need to cool it, and these materials, at least PLA, it's a semi-crystalline material. Okay, so the properties that are good for 3D printing are improving with the degree of crystallinity. So semi-crystalline means that there is a bunch of crystals, crystallites they are called, within a base of amorphous material. The bigger amount of the crystallites, the better mechanical properties and all bunch of properties for the filament itself. So it is important that the material does have time to create crystals. Okay? So you need to cool it slowly.
Yeah, you can't shock it.
Yeah. So actually, we have 3 regions. So we have 2 bays of cooling. The first one is not cooling; is a quenching. Okay. So we do have a portion where the temperature is 80 degrees. Then we have another portion where the temperature is 60 degrees, and then we have the cooling time. And we need to make sure that the filament spend enough time into the warm or almost hot water to make sure that the filament does have time to crystallize.
So basically, you're like a samurai sword. You're tempering it.
Yeah,
essentially.
Exactly. So we get through that. We get to the cool water bay. Then we suck the water with a vacuum from the filament. Then it's going through the measuring system. Then it's going to the traction. Basically, the traction is pulling it. In between the measuring and the traction, there is that feedback loop. And then from the traction is going into an accumulator to run the line continuously while we change the spool.
Okay, so it's a buffer.
So it's a buffer. It's an accumulator. And yeah, there are 20 rollers, and that goes for, I don't know, 4 meters high or something like that.
So as you're changing the spool, it's filling up the buffer, so you just don't have to.
So it gives us about 40 seconds. It depends on the speed of the line, but about 40 seconds to work with the spool. So the line works continuous. So it's 600 meters we are doing right now. We are running the line is doing in about 12 to 15 minutes, something like that. Okay. A spool. A spool of 600 meters, which is in PLA, it's 1.81 kilograms. Okay. Then we have a winder where we wind it. We have 2 stations, so we wind one station, then we change it and put on the other station. And after that, we do have a system that is recording the filament diameter, actual filament diameter, on a label. Okay, so we know exactly 600 meter spool, what tolerance was, what was the minimum diameter and the maximum diameter. And actually, we are using that information to create 2 brands of filament. So one brand of filament is the precision filament. So let's say half of the spools are coming within a tolerance of plus minus 0.02 millimeters. And half of them are coming within a tolerance of plus minus 0.05 millimeters. Many times it's much closer than that. So
so you're always aiming for the precision, and if just one spool just happens to be slightly under, that's
and that what's happening, it's on 600 meters diameter, most of it's within the plus minus, but once in a while is going plus minus 0.03. Okay. We cannot, or 0.04
so once you have
maximum.
that, you can't guarantee 0.002.
I cannot put on the label because it is not.
Yeah.
So that's why we created these two types of filament. So every day, which is fine we are using that all the time because most of the time it's not that important to have 0.02 tolerance. And when we do have prints for customers, we are doing 3D printing as well for them. And we have a precision part, or we are using a precision filament. So that's
I've used both, and I can't tell the difference.
You can't tell the difference.
Great, so.
Exactly. Yeah. So that's what's happening. We put the labor, and after that we put the filament. We have two dryers, and we put the filament in the dryer for another 4 hours. So this is for two reasons. So one is that before we pack it and we vacuum pack it, we want to make sure that the filament is dry. That's important for 3D. Everybody knows that. But the filament still works, the material itself. So it continues the crystallization. Actually, even after we put it in the bag, it crystallizes for another maybe 20 hours.
Yeah, because it's still a little bit warm, right?
Yeah. So it's working. So the crystals are still forming into the material. So by doing that, we are helping it to end well, the whole process. So after we keep it in the dryer at 65 degrees Celsius for another 4 hours, we put it, we vacuum, pack it, then we bag it, and we ship it to the customer, or we have it here. So why we have 600 meters instead of 1 kilogram? What we want to minimize the waste. One side of the spool is 68 grams, so two is going to be 100 and at most 140 grams of plastic. That if you throw away the spool, you are going to waste 140 grams of plastic for 1.8 kilograms of material. And usually what you have is 300 grams empty spool for 1 kilogram. With our filament, it's much lower. Half of it. The second reason is the efficiency of the logistics. It's cheaper and for us, and we are transferring that savings to the customer for shipping, selling on Amazon. Everything is by the kilogram, and the bigger quantity is cheaper to move around.
The spools aren't that much bigger than an average.
They are not.
So
yeah,
they're thinner.
Yeah, so it is on purpose. So basically, a regular spool is 200 millimeters. Ours is 210. It is wider, and
it is bigger. It's got more filament.
It is. Yeah, but it fits on most of the printers.
Yeah.
So, yeah, that's one of the reasons. So basically, this is the process that we are following.
So we are here managing filament manufacturing and 3D printing services. So basically, we want to give a customer a good product. We know kind of most of the issues that been involved in 3D printing, especially related to the filament. Sometimes you have the clogging, you have jamming, and we constantly looking at the market and what are the best material in the market. We buy them, we compare our product against them as far as like a mechanical property wise, how it's printing, what is the advantage and pros and cons. So we know where our product is staying in front of the market, and that's our primary goal, to make sure that our filament is give the best quality and values to the customer, and they have the happy printing and worry-free printing.
Yeah, so you're seeing what the competitors are doing, and you're basically trying to improve on what they're doing.
Yes.
So, and then because you guys do print services, you're constantly looking for the best material that you can run through your print service.
Taylor, for the local market, give a big discount if somebody comes here to take the filament. So we want to make it as economical for people to print as possible.
Which, considering Windsor, Ontario is so big in injection molding and the tool and mold trade, there is like nothing here for 3D printing. I think you guys are the only ones that I've know about.
Yeah,
There's nothing
that
here.
are making here. So there are other people that, but they are importing from
Yeah.
China and
Yeah,
rebranding
they're
it.
just reselling, they're not manufacturing.
Yeah.
So, what's a good way to tell when it's somebody's first time recording a video on location? It's probably the fact that I forgot to record an outro at Replitech. I want to give a huge shout out to Peter and the team at Replitech again for inviting me out for the afternoon. It was a pleasure to speak with you about the manufacturing process of Filament and taking a look at the facility. And I really did enjoy that interview. That interview itself, I will have the full unedited video available for my Patreon and YouTube subscribers. I did have to cut a lot of that out to make it into a more manageable YouTube algorithm-friendly video. If you want to check out Replitech, I do have links in the description as well. Visit their website and get some of their filament. It's actually some pretty good stuff. And again, it does come in those 600mm spools of 1.8 kilograms. So when you're printing those big things, you don't have to worry about doing a filament swap at 2 in the morning. I really hope you enjoyed the video today. I know it's a little bit different than my normal content, but it's something I really enjoy doing. If you want to help support the content I create and the things I do have links in the description. And on the way out, make sure you are subscribed to the channel and like that smash button before you close the door. Cheers, and have a great day.